Hello everyone. So today we are on the day 13 of our DSA challenge, right? The question that we're going to take today is search in a 2D matrix. So the question is fairly simple. You are given an n cross n matrix, with the following properties. Each row is sorted in non-decreasing order. The first integer of each row is greater than the last integer of the previous row. Given an integer target, return true if the target is in the matrix or false if otherwise. You must write an algorithm in O of log m%. Again, we'll, like our usual video goes, this line we'll ignore for the starting. We'll obviously, when you're in an interview, you won't be told like which time complexity or space complexity you have to use, or by which you have to solve it. You just will be given the question, and obviously you will first state the brute force, and then you will in, gradually optimize the approach. Great. So the question is given like this. Let me just copy this matrix, right? Oh, really sorry. This is the matrix given, right? Um, as you can see that this is an array of arrays, so it's obviously a 2D matrix. The target is 3, and you will notice that 3 is present here, right? 3 is present here. If I just font size is this, okay, no problem. Mm, so if this is the font size, can I decrease the stroke width? No, that is the minimum. Okay, no problem. Whatever, yeah. So you can see that 3 is present in here. Now, what is the brute force, right? Let's discuss the brute force. Brute force is simply that you traverse the whole two-tree matrix. So you start your loop from, you know, your loop from I, which will start from 0 and go till, is it m cross n or n cross m? So that's given m cross n. So you will start from 0 and go till m or n minus 1. And you will again start your j from 0, and j will go till n minus 1. And you will see that if my array of I comma j is equals to target, then you're gonna return true, right? And when you come out of the I loop, so if this is a j loop, and no, I guess you can here. So you will notice that this syntax is correct, but it'll be difficult to understand. So basically, if you don't put a bracket here, the first line is executed, and the next line after it is the part of either the either the ma- either it's part of that second line, or it is considered as a separate line, right? So if I say that I is starting from here and j starts from, or I should call it here, this, this. So press and enter. Yeah, this is for J and this is for I, right? And you can this should fairly run. This is the time complexity for it is obviously going to be O of m into n, right? And space complexity is going to be constant since we are not taking any extra space. Great. Um, okay. So this is the time complexity, right? This is the time and space complexity analysis. And you are seeing that you are running two loops. So this is kind of a linear search, right? This is going to be linear search. There is another searching pattern that is known as binary search, right? And what basically, let me just first tell you, like will binary search, why binary search is better than linear search. So basically, binary search runs in O of log n, log base to n, right? Again, the pattern is again simple like in merge sort. You just divide it. Every time you divide it, you work upon either this or this. So it's OR, right? Every time it's going to be OR. You don't use recursion. You just simply say that I'll either work with the left part or I'll work with the right part. I'll ignore the right part if I'm working with left part or vice versa, right? Okay. So before even discussing this question, let's understand what binary search is. Okay. So you are given an array, right? 1, 2, 1, 4, 6, 3, 9, right? This is the array. And I have to find target is going to be my, let's just say 3, right? Or maybe 1. Or maybe let's just say for now, let's take 4, right? Um, okay. So let me first of all tell you that binary search can never be applied to an unsorted array. I wrote unsorted array for on purpose. You cannot ever find using binary search because I'll tell you. So basically, for people who already know what binary search is, you keep a pointer here, you keep a pointer here, right, on the starting and on the ending, and then you find the mid. People who have watched my merge sort video will already know how you find mid. So it's basically L plus H, right? Divide by 2. Obviously, the floor of it. Floor of it. So you find the mid, like where what is going to be mid? 0, 1, 2, 3, 4. So it's going to be 0 plus 4 divided by 2 is equal to 2. So here will we find our mid, right? This is going to be our mid. That is 6. So if I say that, hey, 4 is my target, okay? I need to find where can my 4 be. Okay. Very easy question. Just we'll understand the intuition why the array has to be sorted for a binary search. Okay. This is the array given, right? Your mid is nothing but array of 2, which is equal to 6 right now. Great. Now my target is 4, right? My target is 4. Hypothetically think, if the array had been sorted, if the array had been sorted, where would my 6 be? Will it be on the left side or will it be on the right side? Assume, hypothetically think about a number line. Okay? You just think of a number, or let's just not keep a y-axis for now. Let's just say this is my reference point, that is 0. So 1 dot dot dot. We are here at 6, right? And we'll be 7 and other number. If I have to find my, and I am somewhere, see this is, sorry, if this is my 0, right? Let's just say I am starting from here. My low is at here and my mid is somewhere. Sorry, my high is somewhere here. My mid has come to this point, right? Now I need, like I told you, right? Like I told you in this graph, that you either work with the left part or you work with the right part. You don't work with both of them. You don't work with both of them. You compare your value. Is it going to be on your left part or is it going to be on your right part, right? What is searching? Searching is something that you are searching for an element, and you will obviously say that, hey, I'm searching for an element and I can either be on the left side of the number or I can be on the right side of the number. Pick any random number. Pick any random number. Let's just say this mid is nothing, right? Mid is nothing. Here I am at 5. Even if I randomly pick this number, if I randomly pick this number, again, my target is going to be 4. Now, again, I'll have to think that, hey, Rohan, will my number 4, that is here somewhere, right? That is somewhere here, will be on the left part of my 5 or will be on the right part? Will it be on this side or this side? You will say that obviously, since 4 is lesser than this, and then this number line is already sorted, that obviously then it will going to be on my left side only. So I'll say that, hey, you just ignore all this part and you just work with this part. You just work with this part, right? Again. So I'm standing here now. Now this becomes my high, and this has been my low already. So low plus high, what is it? Let's just not keep 5. Let's simply say 6 only. Let's simply say 6 only. 6 is also included, right? So I'll say that, hey, mid, I know that you are not equal to 4. Mid, I know that you are not equal to 4. So I'm not going to include you in my left part as well because I already know that you're not going to be in my search space, right? You are not going to be in my search space. I already know that you are never my answer because I've already checked you. I already know what you are. I already know that you're a 6. So 6 will never be my answer because my target is 4. So I'm not going to keep you here. I will say that hey, my edge is now going to be mid minus one, and low is going to be same because I don't know what my low is. Right? I don't know what my low is. Right? So I will search from 0 till 5. I will search from 0 till 5. That hey, Rohan, I will say that hey, my low is here and my high is at 5. What is 5 by 2? It floor of it, the floor of it is going to be 2. So somewhere here, my 2 is going to be here, right? If this is the number line, this is the number line, this is the 5, and this is 0, my 2 is going to be somewhere here, right? I'll tell that hey, Rohan, I am 2. 2 will tell me that hey, Rohan, I am 2. Your mid value is 2. Can am I equal to 4? That you're trying to find out. That I'll say no, no, yeah, you are not equal to 4. So I will say that okay, fine. If you are not equal to 4, then what I'll do is I'll search. I'll say that where can my 4 be? Where can my target be? Can it be on your right side or can it be on your left side? Now 2 will say that hey, 4 is obviously greater than me. And since we are in a sorted array, we are in a sorted pattern because it starts from 0 and it goes till 5. This searching space, right? The searching space is starting from 0 and it is going till 5 and everything is sorted. So every number is in increasing order. So 2 will say that hey, 4 will obviously be on my right path because obviously 2 will be somewhere here. And here I can ignore this part because I'm sure that I will never find my 4 here. Okay. I'll say that hey, low, now you shift to this part. Now you shift to this part. And how will I say it? I will say that hey, I know your mid, you are never going to be equal to 4 because I know you are 2 right now and you will never be on my search space because I already know that you are not 4. Why do I need to need to even consider you in my left part or in my right part or whatever my search space basically. I'll say that hey, mid, sorry, simply I'll say that hey, you just move your low to mid plus one. I'll say that hey, L comes here and here is my C, right? So my search space is now this only 3 to 5, 3 to 5. Okay. I will again calculate my mid, right? 3 plus 5 divided by 2. What is it? It is going to be 8 by 2, which is going to be 4. Okay. Hey, I'll say, hey mid, this is my mid value by the way, right? Hey mid, are you here? Are you 4? Your mid will say, obviously I'm here. I am your middle part. I am your solution. You will say then simply. I hope you understood why we can never work with an unsorted array. We can only work with a sorted array because my mid has to decide which search space do I need to consider. Okay, fine. We are lucky that our 4 is on the left part and 6 will obviously say that, hey, 4 will be on my left part only. But what if this is an unsorted array and 4 had been on the right part, right? If we were to search 3, if you were to search 3, then obviously when you are standing at mid, you will say that, hey, 3 exists on my left part. But ideally on in your unsorted array, 3 exists on your 3 exists in your right part, in your later part, right? So this will obviously be this the answer won't be correct. You will return a false, but you will notice that hey, 3 does exist. 3 does exist in my array. So first what you do is you always work with a sorted array. This is your first prerequisite. First, second, you or let me just you always search a middle element and check if that middle element is your target. You will say that hey, if it is the target, so I'll say if it is your target, return the index slash element, else you decrease your search. Now, what do I mean by decreasing your search space? For decreasing, you will say that A is the 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 element which is my target, is it greater or smaller than my mid element? Basically, you will either be on your left part or on your right part, excluding the mid, since you already know what your mid element is, right? I will move it here. I will say that, hey, why don't you come in the next line because people won't be able to see you, right? So, yeah, this is going to be my second approach, or my second, basically, the second thing that I need to do. Now, let's quickly write a pseudocode for it. Let's quickly write a pseudocode for it. I'll say pseudocode. I'll say that, hey, no, you initialize yourself with 0. Hi, you initialize yourself with array dot length minus 1, that is n minus 1. And I will calculate my mid in my loop only. So I'll say that, hey, while my low is less than or equal to my high. Now, why am I saying? Very, very important thing. Okay, great. Where were we? We were here. Let's just say our search space is 3 to 5, right? My search space is 3 to 5. So basically, this is my array given, and this is what I need to search. I am going to, my element is going to be 5. Let's just say this is my target. This is going to be my target. Now, what is my mid? Mid is nothing but 0, 1, 2, which is going to be this. This is my mid. This is my mid. Will I say that, hey, mid, are you equal to 5? You will say no. 4 will say no. Where is going to be your 5? 5 is going to be here. That is on my right path. So I will move my low pointer from here to here, and my high is already here, right? If had I not been running this low less than equal to high, you will obviously return from this part because, hey, low is equal to h now. You will say that, hey, just return. I don't want you to even check. And your element, which was there, which was present in your array, will simply return a false. Your algorithm will return a false. That is why you simply run till low is less than equal to x. Now you say this. First of all, calculate my mid, which is nothing but L plus H divided by 2, right? Great. Now I'll check if my array of mid equal to target, return index, return mid, or if you can return the element, whatever you want. You can do whatever you want. Else if array of mid is lesser than my target. So basically what I'm saying is that my target, okay, my target was 5. Oh, sorry. My target was 5. My array of mid was 4. Is my 4 less than 5? Yes. Right? Is 4 less than 5? Yes. So what I'll do? I'll simply say that, hey, just move your your low to be mid plus 1 because I know this is this means that my element is present on the right side. Else, do nothing. Obviously, if either of two situations can happen, right? Either it's on the left part or it's on the right part because we have already checked that mid is not equal to target. Else, Just simply move your high to mid minus one. Great. You've done your mistake. You've done your thing. And if by mistake never my if never my mid is found to be target, if my mid is never found to be the target, I'll say that hey, this you are not here. I'll say return true. I'll say true, or else I'll say false. Great. Because why? Why am I saying false? Because no, I couldn't find your element. This is the pseudocode. This is the pseudocode. This is how the pseudocode will look. Great. So, I, oh, sorry, but yeah, I mean, hope you understood, right? This is very easy. You can apply it. You can search binary search lead code. Is this tag okay? I cannot find. Yeah, I mean, you can search for the question and you can obviously write this, and this will obviously run. This will obviously run. This is the situation where you can do whatever with your answer. You can return the index, you can return true or false, you can return the element, whatever you want to. This is where you can do. Great. Now coming back to this question, right? Where our matrix was this, right? Where our matrix was this. I already know that each individual, each individual array, that is the child array is sorted. The child array is sorted. Great. Now I am obviously on my optimal approach. Great. I know that hey, every time, let me just turn on my charging for the laptop. Sorry, give me 1 second. Yeah. So I was saying that hey, every array, every child array is sorted. Great. So and my target is three. What if I pick every array? What if I pick every? Let's just say this is matrix. Okay. If this is given matrix, what if I say that hey, I will run a loop which starts from zero and goes till matrix dot length, right? Minus one, obviously. And you will say that, hey, that if binary search or no, not binary search, if searching in array where I'll pass my matrix of I, which is going to be the child array. It will going to be 1D array, and I'll pass my target. If this is going to be true, then return true, right? Else return false, right? And what is a searching array? You can obviously use you can use linear search. Now if you use linear search, what will be the time complexity? Let's just say the searching in array is a function which depends upon you, whatever searching facility of whichever first searching algorithm you want to use. This this is using O of M for sure. This is using O of M for sure. Now your searching in algorithm in searching in array will use O of N. Again, you come down to O of M into N. What good did it do? What good did it do? This was also the same. Where is this? This was also the same O of M into N. So did it do any good to you? No. You will say that hey, my I will take one advantage. I will take one advantage. So here it is written each row is sorting in non-decreasing order. So I know that hey, these particular arrays individually are individually sorted. And if you remember for binary search, you know by now that in binary search, you can obviously apply binary search if the array is sorted. If the array is sorted, you can apply it simply. Great. I will say that what if, what if I use binary search? What if I use binary search? What will be the time complexity? It will be nothing but O of log base 2 and what is the length of it? It will be n. I think we did not discuss the pseudocode time complexity. every time you're dividing it by 2. Do you remember this? Where is it? Yeah, this diagram, right? This this similar diagram was made in um what do you call what do you call that? This similar diagram was made in a merge sort as well, right? When we were dividing everything, and there also we were dividing it by 2. There also we were finding a mid, and we were calculating the left part and the right part. We were merging the left part and the right part, right? What was the time complexity then? It was nothing but O of log base 2n, right? By base 2 because we are dividing it by 2. We are not dividing into 3 parts, we are dividing it into 2 parts, right? This is log base 2. I've already explained why is it log base. It is going to be O of log n in my previous, basically my merge sort video. You can go and check there, right? So we were here. So this will give you O of log m. So O of m into O of log n. Now what does this give? This gives O of m log n, right? This is the time complexity for this. And space complexity is going to be O of 1 because since we are not using any extra space. Great, great. Should we type this code out? Yes, we can do. Okay, no problem. We can do that. Let m is equals to matrix dot length. Let n is equals to matrix of 0 dot length. Number of rows, number of columns, right? This is simply what number of rows, number of columns. I will say that here just simply run a loop which starts from 0 and goes till m and I plus plus because I am finding every element. I am finding every element. I am finding every row. So every row is sorted. This row is sorted, this row is sorted, and this row is sorted. So I will apply if binary search of my matrix of I is, see, this is a 1D matrix, right? This is every child of matrix is going to be a 1D array, right? And then I'm passing the target. If this is true, then return true. Else after it, return false. Simple. Let's quickly write our binary search as well, which takes in an array and takes in a target, right? So I'll say that hey, let L, which is going to be low, is equals to 0 and high will be initialized with array dot length minus 1. Great. I'll say that hey, while low is less than equal to high, I will calculate my mid, which is going to be low plus high divided by, right? If array of mid is equal to my target, return true, right? Else if my array of mid is less than my target, simply move my low, which will be equal to mid plus 1, and move my high to be mid minus 1. We have already discussed why, and if my target is not found, simply return false. Let's try to run. Okay, wrong. Why? Uh, what are we doing here? That is wrong. Array, we are fine. Okay, this is starting from 0 and goes till m. We are taking n here. We don't need it right now. Okay, no problem. What is the problem here? Let's quickly. I have a very beautiful website for you guys, and I am going to search that and I'm going to use that for this particular thing, right? Let's just say this is my website, okay? It will give you a visual interpretation of your code, right? So we'll try this. We'll just copy our code and we'll say that hey, search matrix, and I am going to pass in my matrix that is going to be nothing but these things, and my target is going to be 3, right? Let me visualize this execution, right? So this is my global. This is you already know what a global frame is, right? So I this is my global frame. Great. So matrix. This is my matrix given. Right. M in null calculated. Okay. I start from 0. Array is here. This is my array. First array. My target is 3. Okay. While low is less than equal to high. Okay. This will be the next line executed, right? What is my mid now? Mid will be calculated as 1.5. Great. Yeah, I have already found the mistake, and which is nothing but this here. Math dot floor. I every time forget to do this, and this is something that I need to every time consider. And I think you will be able to solve it. Great. You are able to solve it. Let's try to sum it. Did you see that here my mid is 1.5, and this is how I knew that hey, my code will not run. Accepted 90.97 users. But here now you will notice that here it is written, hey, you should have to write a log of m cross n, m into n. But what is the time complexity right now? It's m log n, right? So we need to boil it down further. We need to boil it down further. Let's now discuss our optimal solution. So solution, great. Where is my matrix? So this is my matrix. I will obviously bind it with final matrix. Great. This is my matrix given. Okay. The second line is given that first integer of each row is greater than the last integer of the previous row. That what does it mean? That hey, this 7 is less than 10, 20 is less than 23. Okay, there is no other array. But had it been an array, here it would the next. Can you guess with from if there was one more child? If there was one more child, from which element would it start? The minimum element would be 61. The minimum element would be 60. Why? Because the last element is 60. So it has to be. The first integer of each row is greater than the last integer of the previous row. It has to be greater than it has to be greater than this last, right? So let's just simply remove all these things. Okay. Now, now let's consider. Can we can we hypothetically think that this is nothing but a 1D array. Now, why am I saying a 1D array? Because every element is in a growing pattern, is in an increasing pattern. Now, why am I saying that? Because the last element is lesser than the first element of the next row, right? So I can say that hey, when you write it, you will simply find this 10, 11, 16, 20, 20, 30, 24, 60. If I write this 1D array, am I breaking any rule? Am I breaking any rule? No. Which rules am I not breaking? These two rules. Each row is sorted in non-decreasing. Is this non-decreasing? Yes. Is the first integer of each row? Basically, you will notice that this is again a non-decreasing order. Basically, ascending order, right? Can I now can I now apply my binary search in this thing? So okay, where will my low be? My low is equal to 0, right? Where will my high be? If you get what where your high will be, you're almost sorted. You're almost sorted. There is one more thing that you need to understand, and then after that, you're very much sorted. Where is my h? Obviously, what is the length of this hole? What is the length of it? It is n. And what is individual? Sorry, this is m. And what is the individual length? It is n. And what is this length? This is something. Sorry, this is n cross m, right? 0, 1, 2, 3, and blah blah blah. So where will my h be? It will be nothing but n minus n into m minus 1, right? Since it starts from 0 and this is n into m minus 1, and this is where my m will be. Great, great. So you now have understood where my h and low will be. Great. Can I find my mid? Yes, you can find your mid. You can by L plus H by 2. Great. You can do that. Now you've already done almost everything. Almost everything. But there is one more situation that I need you to understand. This one is what? Is at what condition? Is at what index? It is not at 0. It is at 0, comma 0. Right? Similarly, this 3 is at 0, comma 1 and dot dot. If I have to write for 16, where it will be? It will be in my first row. So obviously my X column will be first. And what is my Y? It is going to be 0, 1, 2. This is going to be the indexing of 16 when you are writing a 2D matrix. When you are writing a 2D matrix, this is where my 16 will be. Great. Great. I have my low in 1D manner, H in my 1D manner, mid also in my 1D manner. But my elements are in a 2D manner, are in my 2D manner. How can I find my, how can I find the exact index? Great. What if, what if I write something like this, that, hey, okay, how do I make you understand this? Hmm, okay, okay. So let's just say my mid is something like, let's just say we are trying to find 3. We are trying to find 3, okay? And my n into m is nothing but, what is it going to be? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? H is going to be 11. What is my mid going to be? Mid is going to be 5. The floor, the floor value will be 5. Okay. If this is your mid, and I have to, what is my fifth element? 0, 1, 2, 3, 4, 5. This is my mid. 0, 1, 2, 3, 4, 5. Yeah, this is going to be my mid. How will I find my indexing, my 2D indexing? Great. What if I divide by 4? What is it going to be? What is it going to be? You will say that, hey, Rohan, it is going to be 1. Obviously, I'll take the floor. I hope you're aware of it, that I'm taking the floor every time. It is going to be great. What if I give you a modulo? Now, what is a modulo? Modulo is the remainder. Is a remainder when you divide something, right? What is the modulo of 4? It is going to be 1. So if you divide your 4 with this, or sorry, if you divide your 5 with 4, you say that, hey, 1 is this, and this is going to be your division. This is going to be your division, right? And this 1 is left. This is going to be your remainder. Again, 1 is your remainder. I'll say that, hey, this forms 1, 1 comma 1. Okay. What is 1 comma 1? This is 0. This is 0. This is 1. This is 2. Right? So this is my one first row. And what is my first column here? Sorry, my first element in this. So it's 1 comma. What is at my first this index? 0, 1, 2, 3. Oh, 11 is at my first. 11 is my first index in this particular row. 1 comma 1 are low. My mid was this, and my mid was 5, and my mid element was what? Mid element here was 11 only. It was 11 only. It is nothing but 11 only. And if I do these particular things, which is giving me this index, that is 1 comma 1 for a 2D matrix. What I'm finding at 1 comma 1? It's 11 only. Wow, that is great. That is great. Okay. What if I take 34? What if I take 34? Now, what is my 34? 34 is nothing but 10 in a 1D matrix. The index is going to be 10, right? Great. What if I divide it by how many rows are there? How many rows are there? There are, what is the M? Now M is 4. Now why is it 4? Because this is 4. Okay. So what if I divide by 4? You get the floor as 2. Great. What is my modulo 4? Again 2. Okay. Okay. Let me search in my 2D8. This is 2. So here is my 2. And this is 0, 1, 2, 3, 2. What did we find? We found 2 comma 2. What is that 2 comma 2 in a 2D matrix? It is nothing but 34. Hey, we have figured out the row and the column. We have figured out what is row and what is column. Can I copy this? Copy image. What if I try to paste it here? Oh wow, great. Sorry. What if I try to paste it here? Okay. 0, 1, 2, 0, 1, 2, 3. Wow, great. Let's just say 16 is something that I'm able to trying to find out. Okay. When you divide by 4, when you divide by the length of your row, when you try to divide by length of the 4, you know how many rows are exonerated, how many rows are not considered. So zeroth row will never be considered. Either you will consider your first row or your second row, and you will know that when you divide this thing, you will find that this is going to be 1, right? When you obviously in this 1D matrix, you will find 15. What is the index in the 1D array, and then you will divide by 4. This simply means that you are removing this array, and this particular, then you are finding it here. Great. Now, what does remainder remainder give you? What does it signify? It signifies that the particular what is the particular index in that particular array, right? The remainder. How many remaining things are there? How many remaining things are there? There are 2 remaining things, and this is where I will find my 6. When you do the math, you will understand it more clearly. Great. Now that we have already discussed, is there anything else to discuss? No, no, because you are simply going to apply binary search. Let's try to do that. Let me keep my binary search as it is. My I will remove this for loop only. Great, great. What will I do? I will say that hey, just find, let, return this, and I will remove this. My what will I? And I will pass my matrix. I will pass my target. I will pass my length and m, my length of row and my length of columns. I will improve this a little. This is array. This is target and row length, call length. Great. Okay. Great. I will remove this while loop. Or should I do that? I should not. I should not. This is nothing but um what it is going to be. It is going to be row length into call length minus 1. Was this what we discussed? N into m minus 1? Yes, great. While low is greater than equal to high, it is going to be math.floor low of here till here we are correct. But here we need to calculate our let's calculate our 2D indices, right? Great. Let row is equal to what will it be? It will be mid divided by my row length, correct? Yeah. What will my call be? It will be mid modulo row length. Great. If array of row and call equal to target, this is it going to be. Okay. Now what is it going to be? If this is this here, am I copying it? My low will become this, and let's try to run it. Okay. Cannot read properties of undefined. That is 2. Why are we doing that? What is my row length? Okay, I think I need to divide it by n and not m. Sorry, sorry. Call length. Let's try to do that now. Again, it is giving me something. No problem. What we'll do is we'll just simply do in my matrix, in my Python tutor. By mistake, I ran the same code. Sorry, I will remove this. I will apply this. Let's see what's the problem here. Okay, it says cannot read properties of undefined. Let's start from the first. Binary search. Okay, L- target is this. Row length is this. Okay, no problem. My I is going to be this. Math dot floor is going to be 5. Okay, let's calculate the row. What is row? Row is mid divided by call length. That is going to be call length is 4. So it's what is my mid? Mid is going to be 1. Okay, again, I think I did the same mistake. I did the same mistake. I need to calculate the math or float. Let's try to run them. Why? Why? Why do I every time forget it? Why do I every time forget to add math.float? Great. Both of our cases are accepted. Let's try to submit. Great. Accepted 68, beat 68.88 users of JavaScript. Great. Let's remove this and let's quickly discuss what's the time complexity. What's the time complexity? What was the time complexity when you apply a binary search to a sorted 1D array? What was it? It was nothing but O of log n. Okay, great. Now, what is this length? What is the length of this particular array that we are given? It is nothing but n into m, right? What is the length of this array that is given? If I copy this array, I paste it here somewhere. What is the length of it? Its length is nothing but n into m that is already given. So what will the time complexity be? Hey, it is going to be log base 2 of n into m. What is a space complexity? It is nothing but O of 1 because we did not use any extra space. Was this given already in the question that hey, you have to use m cross n? Sorry, it is m cross n. Doesn't really matter anything you apply. We have successfully solved our question in O of log m cross n, m into n. Thank you so much for joining in. Let's obviously, why do I say thanks for joining in? Let's just type it. You need to use binary search and hypothetically think that the given 2D matrix is a 1D matrix since it is increasing in every manner. Row call wise. Great. Now calculate the 2D indices. Your row becomes mid divided by call length. Your row call becomes mid modulo call length, right? And you simply then just simply perform BS. That is why this much. Let's try to save it, delete them. Okay, and done. We are done. Thank you so much for joining in. I'll see you tomorrow with another question that is power x comma n. So we'll solve this question on lead code, and this is also going to include binary search. So you need to obviously know what a binary search is. Thank you so much. See you tomorrow.